darn it, I had people absent yesterday and I forgot to record, so I was going to record you guys. Atom, element, atomic, mass number, good. Shivan, I still see some blank. Vivian, good. Whiteboards. So I cannot see your thinking if you're not putting anything down. And this is something you should already have notes on because this was last week. Right, good. I see Heather and Jason. Isla. Audrey's getting there. Ashley, I don't see anything yet. Gavin, I don't see anything. Jason L. Lorelai, Luca, Maya, Mia, Mina, some of you, I don't see anything on your whiteboards. I know that there's a, make sure you refresh your whiteboard to get access. There's Mina, good, and there's Mia. Okay, I'm gonna do a capture real quick. One of the things I'll be doing is collecting evidence of participation, but also just so you know, teachers have to do this for multiple reasons, like keeping our certificate that we actually do check on you and your learning. What is today? 10/13/2020. My dad's birthday is tomorrow and I still don't have a gift. I have no idea what to get. Okay. See. Right. So I could save your guys' screens at any time just so I can see how you're doing and look back at it. All right, moving on though, then we talked about radioactivity. And this is the one that I'm going to kind of do a kinesthetic activity next week on. But an atom with the same number of protons but different numbers of neutrons, the prefix of this means same, like same triangle that has the same sides. We always talk about it being this kind of triangle. This is something like carbon 12 and carbon 14. So they're both carbon, but so they both have the same number of protons, 6, and differing number of neutrons. And then what is this spontaneous release of material? One of the puzzles I'll have is going to talk about alpha, beta, and gamma decay. And these are different particles of matter and material that are released during this process of trying to become more stable. And those all have different levels of energy. So some will penetrate the skin and some will not even penetrate a piece of paper. Knowing about that release is important as well in terms of how you handle that material. And then the last one, be prepared to work problems where you figure out how old something is based on the ratios of these different elements and their decay products, often called parent atoms versus daughter. Okay, so I see Audrey, I don't see anything. Gavin, I still don't see anything. Jason, there we go. I see Jason now. Luca, Lorelai, Maya. Yeah, good. Still missing, I see white blank words. If you are having any issues with your whiteboard, just make sure you type it into the chat box. But Heather is correct. If you click somewhere on the whiteboard and then press enter, then I can see it. So you might be typing yes, but I can't see it till you show me it. Laura, let me see. Yes, I can see yours. And you have them all correct. So I can see Arab, Adith, Ashley, Audrey, Isla, Emilio, Gavin, Heather, Jason, Jason L, both Jasons, Jesse, John, Joshua, Laura, Leo, Luke, Maddie, Mia, Mina, Ryan, Savannah, Shivan, Tommy, Tyler, Vincent, and Vivian all have things on their whiteboard. If I did not say your name, It's because you're up. Now I see more of you. Okay. So now, all right, we're going to move on. So it is isotopes, radioactive decay, and half-life. Then we talked about different kinds of bonds. And you guys had an ed puzzle in this. It was a crash course. And then there was one, I remember looking at your answers. Some of you were able to put the sparkles around that third one. So what were those names of those bonds? Good. I see Laura and Jason and Jesse, Emilio. Enzo, I can see yours. There you go. Yep. Yes. Right, still, I'm going to capture this one. So if you have an answer, you have about 5 seconds to press enter so I can see what you have. Good, Gavin. There we go. John, Joshua. Capture this. Bonds. All right, so covalent bonds, they are both sharing to be more stable. These tend to be stronger bonds. Ionic is giving away an electron. If you give your electron away, it's negative, so you become positive, which is a cation. If you're gaining that electron, that becomes negative, so they're an anion. And what we're going to talk about with water is this hydrogen bonds, and water is a polar molecule. So anything that has a slightly different charge on one side than the other is considered to be polar. And that's just showing you that there's more electrons on this side, at least spending more time on that side, closer to this more massive oxygen that has the more protons compared to the two hydrogen that only have one proton. Okay. This is where we're at this week. So can you name 5 of the 6 properties of water? So we are going to mess around with water. So for your next live session, on the weekly agenda is a list of materials if you want to play along and try the different activities. One of them I've done for years, but one of them I just did at a workshop that I thought was very interesting. I'm not very good at it. It can be done. I will show you how to do it, but it's called upside down water. I just made big messes, so you will want to be by a sink or have a tub with you for the next class. Good, I see. Vincent and Shivan and Tommy and Savannah, Ryan, Amina, and Mia. And Luke's getting there, good, and Savannah. Leo, good, Laura, John, Jesse, Jason. I would love to get a PDF here with all of you with something on your whiteboard, although I can talk about things and reasons for nothing on your whiteboard as well when I submit my evidence. I will conjecture on why kids are keeping their screens black and not having anything on their whiteboards. There, Tommy and Tyler, good. Okay, almost have most of you something on here. Audrey, good. Called properties of water. Okay. So we're going to try to use this vocab when you explain the demonstration. So when we mess about with the water, I want you to see how many of these terms you can start applying to what you're seeing. So cohesion, being attracted to yourself, anything where you see the word co, it's something working together. So adhesion, like an adhesive, is things like tape and glue, right? You're sticking two things together that are different. So water with something else. Surface tension, just like a water strider going across that. Capillary tubes are little thin tubes. So how water gets from the ground and the roots all the way up to the leaves and comes out these little holes called stomata. That process is capillary action. And then you already did an Edpuzzle, but if water didn't get less dense when it freezes, right, it would sink like regular solids, and then we wouldn't have anything in our lakes. It would be a solid block of ice, or in our oceans, we would lose all of our water on this planet. This is a really big one, universal solvent, when we talk about pollution. So if you dissolve in water, the issues that we have with you as a pollutant are different than if you dissolve in things like fat. So if you're dissolved in water, it's really hard to clean it up if it gets below ground and into the groundwater. So cleaning up water soluble things, which is what a lot of things are, which is why it's called a universal solvent, which means to dissolve. That's a problem. But if it dissolves in fat, whatever it is, like heavy metals, like when I keep seeing my children dump dead AA's into the garbage can, that's hazardous waste, has cadmium and things that should not go into our local dumps. Those things deposit in our fatty tissue and they stay there. And if that builds up in your brain, it can cause a lot of neurological problems. So these properties of whether you like water or don't like water will become important when we get into more pollution studies. This is just a look at a bunch of water interacting with itself. But we are going to come back to that in our next session, see what all you remember about those properties and look at them like in kinesthetic models and demonstrations. We are going to now talk about your lab, so your biodiversity lab. So last time, what I want to show you is under classwork. So if I was on your guys' stream page and I click on classwork and I go to this week and then I click on, and I know I'm going fast, I click on biodiversity lab. You can see that I was already doing this. There's 3 attachments I want to draw your attention to. Gabriel. Sorry, so loud. This is your Jamboard from last time with all the different topics. Okay, this is the Google Slides where you're going to, with a team of up to 4 people, claim a slide. So I'll talk about this in a minute. And this is your actual lab that we already had last week. So I'm going to open this one, the actual Google Slides, because what you're going to be doing today is you're going to choose a slide for your team. Once you form your teams, you're going to choose roles for your teammates. So you guys are going to decide who is the techie of the group, who is very good with apps on their cell phone like Seek or iNaturalist, who's good at organizing data into charts and graphs, okay? Who is good at running around outside and using field guides and trying to take pictures and identify what's out there, okay, and getting a record of it. Who is going to be your recorder and your timer? So keeps your group, what I call the facilitator, keeps your group task oriented, gives your group a timetable, records information from the biologist and anybody else as needed. And then who's your leader? So who is going to come and ask me questions if there's clarification needed, or reports out the results at the end of activities and helps with any other tasks that are taking longer than your group planned or that need help with. So those are the roles. I'm going to try to keep that up here, but first I want you to have some time to talk with your group about the different topics. And what I did yesterday that went faster than I thought was I can open all the rooms. You can't choose them. But I can put you in them. So what you're going to see when I open the rooms are all the choices that I took from your Jamboard. So I took the backyard versus front yard, the riparian zones, which is the areas along creeks versus rivers, in the sun versus in the shade. So you're going to see all those choices. And I also put other, just in case the one that you wanted to do isn't on here. Okay, and I'll put all of those others in a room. So as I go through your name, you're just going to tell me, I want to be in the backyard. I want to be in the riparian zone. I want to be in the sun versus shade. Okay. And then I'll just put you in there and you're going to talk with the other people that are interested in that topic about what's a question you can ask. So what's a good investigative question today? Okay. So the rooms are open, and my understanding though is that you cannot go in them. So Laura, you were at the top of my list. Which one of those, back versus front yard, riparian zones near creeks versus rivers, and just unmute yourself, and sun versus shade, park 1 versus park 2, now versus 10 years ago, or other? Where do you want me to put you?
Front yard or backyard?
All righty. Addith, where do you want me to put you?
Sorry, where do we see which ones they are? Where they are?
They are, I don't know if you, here, let me share my screen, then you guys, it should show you the room choices, but